Good morning, Doctor and everyone. So this presentation is for ECC3852 digital signal processing, and our project is audio equalizer for music, and presented by Kehui Yingjun. And this is my group members, and my name is Kehui with metric numbers 218654.
My name is Zhang Yiyu, metric number 28636.
And my name is Zekun, my metric number is 218655. So this is our presentation outline, and skip this page. So let me introduce our project. So for this project, we use the digital signal processing techniques to analyze a really music signal and support audio equalizer design. DSP enables controlled and repeatable analyze. Before analyze, the audio was converted to mono, DC offset was removed, and peak normalization was applied for frequency domain analyze. And for the objectives, next page. For the objectives are to analyze time domain characteristics, investigate frequency domain energy distribution, and use the result to guide multiband equalizer design. Next page. This table we used, we select the audio is an MP3 music track with a sampling range of 44.1 thousand Hz and a duration of about 256 seconds. The stereo signal was converted to mono for consistency. The normalized signal was used for peak analyze, while the normalized signal was used for FFT and the spectral comparisons. Next page. So for the time domain analyze, in the time domain, the maximum absolute amplitude and its timestamp were identified. This peak represents the largest instantaneous value and provides a headroom reference to avoiding clamping during equalization. So for the frequency domain analyze, the FFT magnitude spectrum shows that most energy lies in the low and medium frequency range. The dominant peaks appears at a very low frequency, reflecting rhythmic and evocative variation rather than pitch. The FFT provides a global spectrum, but does not show time varying behavior. Our spectrum will show next page. So next page. Yes, this is our frequency domain spectrum. So overall, the analyze shows dominant medium frequency energy with high frequency components contributing to caloric. These observations directly motivate the three-band audio equalizer design.
The time frequency characteristic of the audio signals were analyzed using short time Fourier transform. The window length of the 30 milliseconds with 75% of the overloop was selected to ensure that the data length per window is small enough for the meaningful analysis, while achieving a balance between the time resolution and the frequency resolutions. And the point represents where the signals have the strongest, lowest spectral energies. And the spectrogram shows that the majority of the signal energies is concentrates in the mid-frequency range. Next page. So this is a 3D waterflow plot is used to provide visual comparisons between the mid-frequency and the high-frequency energies distributions. Mid-frequency energies is strong and more consistent than the treble energies. And this visual contrast helps to identify dominate the frequency regions, which is used for EQ designs. Due to access scaling space and the treble difference are not always clear show the 3D plots. So the bound energy ratios analysis is used later for quantitative comparisons. So next. So this is our GCRs. It's used on addiction time domain features to analyze the waveform characteristics of the audio signals. A zero crossing can bring the signal change lengths between consecutive samples. A higher GCR indicates faster waveform fluctuations and stronger high frequency content. The ZCR varies over time, which indicates that the audio signals is non-stationary. Regions with the higher ZCR values corresponds to more rapid waveform changes, while the lower ZCR values indicate small signal segments. Next, this is of our noise characterizations. Short audio segments from 0.1 to 2.3 was selected as noise dominated regions with minimal music context. The time domain analyzer showed low amplitude, non-period fluctuations, which is consistent with the background noise behaviors. The frequency domain analysis was performed use one-size FFT with HANA windows to reduce spectral leakage. And the results spectrum indicates that the background noise energies is distributed across the multiple frequency components rather than concentrated at a single frequency.
Okay, so next I will briefly introduce our three-band equalizer design. So from our previous frequency analysis, we observed that the mid-frequency band dominates over all energies, while high-frequency content appears intermittently. So based on this, we define three frequency bands. The low bands from 0 to 250 Hz, the mid band from 250 Hz to 4K Hz, and high bands from 4K Hz to 20K Hz. So for implementations, we use the window FIR filters. FIR filters are stable and have near linear phase, which helps preserve audio quantities. And hand window with a filter orders of 256 was applied. So for the design settings, we choose low band gain 0 dB, mid band gain is -3 dB, and high band gain is +4 dB to reduce mid band dominance and improve clarity with a modest treble boost. So next, we evaluated the equalizer performance. So first, we compare time domain waveforms on the three extreme preset. So max bass, max mid, and max trebles. So results show that band boosting mainly affects signal amplitude, while the overall waveform structure is preserved. And next, we analyze the spectrograms. So max bass concentrate energies in low frequencies, and max mid enhance the mid band, and max treble increased high frequency energies, confirming that each band is enhanced as intended. And we also compare the FFT magnitude spectras, so which clearly show increased magnitude in the boosted band, while other bands are relatively attenuated. So for the design settings, the spectra shown reduced mid-band energy and a moderate increase in high-frequency content, resulting in a more balanced sound. And finally, when analyzing the band energy ratios, since that ratio is a percentage, changing the mid and high band alters the total energies, which can cause the low band percentage increase, even GO is 0 dB. And in addition, we implemented the real-time GUI equalizers. It supports real-time playback with adjustable bass, mid, and treble sliders, and provides live visual feedbacks during playback. So due to the time limitations, we will not demonstrate it live today. Instead, a demonstration video link is provided for reference. So to conclude, our group analyzed the selected audience with waveform FFT spectrogram method, supported by supplementary features such as zero crossing rate and noise characterizations. So based on this analysis, we designed and evaluated the three-band FI equalizers and implement the real-time GUI to demonstrate practical and interactive audience controls. So that's all for our presentation. Thank you, everyone.